What geometry principles are essential for engineering? Imagine building a bridge or designing a new car. Behind the scenes, a lot of math is happening to make sure everything is safe and works perfectly. That math is based on core geometry principles. These ideas help engineers create structures that are strong, reliable, and efficient. Let's explore what these principles are and why they matter so much. First, understanding points, lines, and angles is fundamental. Points mark exact locations, lines are straight paths, and angles show how lines meet or cross. Engineers use these to define shapes, measure slopes, and figure out forces acting on structures. For example, when designing a roof, knowing the angles helps determine how much weight it can hold. Triangles are especially important in engineering. They are the simplest polygons and provide stability. The Pythagorean theorem, which relates the sides of right triangles, helps engineers calculate distances and lengths accurately. For instance, when building a ramp, knowing the length of the hypotenuse and the height ensures it is safe and accessible. Congruence and similarity are also key. Congruent shapes are exactly the same size and shape, while similar shapes are proportional but different in size. These ideas help when creating scaled models or prototypes. Engineers can test a small version of a bridge and then scale up their design, knowing the proportions will stay consistent. Circles are everywhere in engineering. Whether designing gears, wheels, or curved bridges, understanding the properties of circles is essential. Knowing the radius, diameter, and circumference helps in calculating how much material is needed or how parts will fit together. Concepts like tangents, which touch a circle at only one point, are used in designing mechanical parts that move smoothly. Coordinate geometry is another vital area. It involves plotting points on a grid using and y coordinates. Engineers use this in computer-aided design software to create precise models. For example, designing a complex machine part requires plotting multiple points and lines accurately to ensure everything fits perfectly. Symmetry and proportions also play a role. Symmetry makes structures look balanced and pleasing, while proportions like the golden ratio help in designing both functional and attractive buildings or devices. Symmetrical designs distribute weight evenly, making structures more stable. Three-dimensional geometry is crucial for understanding shapes like cubes, cylinders, cones, and spheres. Engineers calculate volume and surface area to design everything from storage tanks to engine parts. Knowing how these shapes relate helps in creating efficient and safe designs. Transformations such as sliding, turning, flipping, and resizing are used to manipulate shapes during the design process. These help engineers test different configurations and optimize their structures. For example, rotating a component can reveal the best fit within a machine. Finally, trigonometry, which is closely linked to geometry, helps in calculating angles and distances. Engineers use it to determine forces in bridges, analyze the trajectory of moving parts, or measure slopes in construction projects. It's like a toolbox for solving real-world problems involving angles and lengths. If you want to understand how engineers design safe bridges, sturdy buildings, or reliable machines, mastering these geometry principles is essential. Practice solving problems involving triangles and circles, learn to use coordinate systems, and explore how shapes transform. These skills will prepare you for future studies and help you see the math behind many engineering marvels.